Hello, everyone. Thanks for coming. I think the first step in building resilient applications on Azure, or resilient applications at all, is identifying the need to build resilient applications. So you're halfway there. Thank you for coming. Now let's talk about how do we make it happen. So this presentation is going to be pretty packed. I am going to do some overviews from the platform perspective, what we are working on, what are the features in preview, what are the features in production. And as I do that, I hope I can shed some light for those who are not familiar with HA concepts about how to implement high availability on Azure or even high availability at all for your application. So I'll try to make it as from one perspective, as basic as possible to explain what I'm trying to achieve and what are the concepts. And from the other perspective, I will add the new features and the new concepts so that those who are familiar with the basics can also get value. So let's start. My name is Igal. I am in Azure for 9 years. Wow. And my focus areas are fundamentals, anything that has to do with fundamentals for the platform. This includes availability, performance, and things like that. And let's go. Sorry, one last thing. Any questions, please keep those to the last couple of minutes. And I will also be available after the discussion, and we'll be happy to share with you. We'll be happy to give you some answers. So before we dive into high availability and the concepts, let's define some basics. The first one is, what is high availability? So when we talk about high availability, we generally start from assumption that there are multiple replicas of the app, or the app can sustain a certain failure. App is divided to certain fault domains, and one fault domain going down is not expected to take down the entire app. So the customer experience will continue being served despite the fact that a certain fault domain is down. When we talk about disaster recovery, we generally talk about a slightly different concept. We talk about what happens if there is disaster and the whole region or the whole set of capacity goes down, and we need to take an app and make it working either from elsewhere, from regions that is unimpacted, from locations that is unimpacted, and maybe move the users there. In many cases, disaster recovery and HA are different concepts. In some cases, they are the same. There are a lot of standardization around those areas. When deciding what the goals for your application, you should definitely consult the compliance and the organizational requirements. And of course, there is a backup. And backup is not disaster recovery. Backup is not high availability. Backup is ability to restore your app from some backup, incremental backups that you've made earlier. And so it's important not to confuse, because otherwise the goals are getting diluted. So once we understand those differences, let's start talking about what we offer in Azure. So this is diagrams they kind of show in every talk, and it kind of just gets the basics. Let's define those basics. Azure offers SLA for a single VM, and this is mostly relevant to traditional applications you cannot change. You are going to the cloud with traditional application. We are offering that with premium storage. We are, by the way, the only cloud that offers 3.9 SLA for a single VM. And let me just be transparent with you. I will talk about this in the next slides. But if our apps were, our VMs were running in 3.9 availability, we wouldn't be in this business. We are definitely running at much more, much closer to 5.9 for every VM. But nevertheless, this is a commitment, the basic commitment we make. I would be super careful with putting any of my production application on a single VM just because it can go down, and your customers will go down. And so the question is, what are the constraints? How are we getting to this configuration? Is it possible that I just cannot deploy this application on multiple VMs? There's some technical limitation. I don't have the code. I don't have the vendors that is working with me who developed this application in the past. Whatever it is, we do provide SLA for this type of configuration, but this is definitely not the best way to go. And by the way, if you're running in a single instance VM, any maintenance you do to that VM will still impact your customers. And so it's not just maybe I won't get impacted because the platform is stable. I will get impacted because from time to time I deploy security patches. So second step is isolation within a DC. We offer SLA of 3 nines and a 5 for that. The idea is that we have multiple fault domains within data centers. Think of racks, different separate racks. And we will make sure that when you are deploying your application, your VMs will not get to the same racks at the same time. So essentially, we are guaranteeing anti-affinity of your VM instances. This is high availability. Latency is awesome because it's within the same data center, close enough. However, if there is a disaster that strikes entire data center, application can go down. Regional availability, this is when we are talking about availability zones. We offer 4 nines SLA for that one. And once again, of course, the system is running at much higher SLAs, but at much higher parameters, sorry, not SLAs. But this is the SLAs that we commit to. And when we are running our application across zones, we can sustain entire zone failure. One zone will go down, but the application will continue running. So for that specific configuration, we need to keep in mind that latency will be higher across the zones. Not all the applications would sustain that latency, and this is definitely a point to consider when identifying the right configuration for you. Many of our customers will choose to run in intra-DC isolation configuration just because otherwise the latency becomes unbearable. So it's really important to tune it specific for the application, but definitely the best possible HA scenario would be to run across multiple zones within the same region. And of course, there's a question of global scale. When you are going to global scale, you start thinking about questions like data residency. Where should my data reside? What's my primary region? Where do I, in case of disaster, let's say there is a flood that flooded the entire planet, there is an earthquake, how do I recover from that? Is there a region that can pick up my load for disaster recovery? And this is essentially the global scale applications. We do have certain guidance around those. If your application is big enough, grows to be big enough to require such a functionality, you should take a look into documentation around region pairs. Let's start with legacy apps. So I'm starting from single VM. And it's important, once again, to talk about single VM because in many cases, we just cannot deploy the application in real high availability scenario. And so I will share with you the efforts we are taking in order to get better execution environment for a single VM, and then we'll start talking about how do we change our application and how do we deploy our application in a multi-regional environment, multi-fault domain environment. And so one concept that we defined, and I'm actually really proud of that concept because it's a really customer-looking concept. We call it AIR, Annual Interruption Rate. And so roughly, assuming that the failures are very short, it's 1 divided by MTBF, mean time between failures. But what's important about this parameter from platform perspective is that we are looking into customer interruptions. And so we came to conclusions that 5 nines, 3 nines is not interesting, is not important. When application goes down, it goes down, and we need to make sure it comes back up. If we were able to restore your VM very quickly, but there was still an interruption, it's still bad. There was an interruption in delivery. And so I think as we are going into cloud and into hyper-available scenarios, we really need to get to a point where we are avoiding every possible interruption to the platform. And so we define this here, and all of our internal systems, all of our internal SLIs, service level indicators, are actually based on count of those interruptions. And this is pretty new, but this is the outcome of our discussions with customers and our attempt to understand what will really make the difference for you guys. So just an example, AIR of 10 means that VM could be unintended, AIR in reboots of 10 would signify that VM would be unintentionally rebooted every 10 years. On average, once again, it's all statistical. But nevertheless, this is how we are looking into the availability of our system. We are looking into networking, into reboots. We are looking into what we call blips and pauses and things like that. But bottom line, we are looking into all of those interruptions and measuring the frequency of each one of those interruptions. And so why AIR was interesting for us, another aspect, is that AIR is a composite. If you think about MTBF, it's very hard to add it together, but AIR is easily addable. So if I have 3 components, and every component is polluting air by a certain degree, I can just add those 3 pollutions together, and this is my total air that system presents. And so, and once again, I'm assuming that the recovery is relatively fast, relative to uptime, then this calculation works. But essentially, air, from our perspective, can be easily attributable to the specific component in the platform that's polluting. And it's also attributable to customers. We can see what's the air for a specific customer. And so from that perspective, the fact that the platform maybe on average behaves awesome, but one of the customers has higher air, that's also an actionable item for us to understand what's unique about that specific application. And definitely I'm sharing that because those concepts could be useful in your applications as well. So I just showed here some timeline of where we got through from when we started this set of projects in 2014 until today. And I'll talk about some of the investments, but definitely a lot of investments through the years. Who was here in Mark Rusinovich's presentation when he talked about Tardigrade? Okay, a lot. Cool. So I won't repeat too much, but our current focus is definitely around Tardigrade. I will talk a little bit about it when we get to the specific topic, but awesome, most of the folks know what it is. Cool. So 3 types of downtime that I would like to differentiate between when we are talking about availability. First one is unexpected, unpredicted. Think about this as system has failed, machine went down. There's nothing I could do to avoid it. Got it. Second one is unplanned maintenance event. This is funny, unplanned maintenance. There shouldn't be unplanned maintenance. However, if your telemetry systems are good enough, you can predict failures, and this is what we are doing. For example, you could predict disk failures based on certain parameters around their behaviors. You could predict memory failures, CPU failures, things like that. And so when we predict that one of those failures could occur, I'll give some example later in the slides, but when we identify that this is about to happen, we can go and perform this emergency maintenance, hopefully with lower impacts than just unexpected and unpredicted downtime. So think about it as if we know that this disk will fail, we will just live migrate the VMs out of that specific machine so that customers are not impacted. And so this is the second type of downtime. Third one is, of course, the planned maintenance events. And when I say planned maintenance, I'm really hoping that we are definitely not rebooting the machine, not taking anyone down. It's just around changes that we apply to the system in a safe manner, hopefully without anyone noticing or anyone being impacted. And those changes are well planned in advance. So if I'm looking, and I'm starting with updates first. If I'm looking to update mechanism, it's all around customer impact. We start with customer impact, we end with customer impact. We will attempt to perform updates with 0 impact if possible. If we cannot do 0 impact, we'll go and perform in-place update. I'll talk about how it works in a moment. We'll do live migration if nothing else works. And in the worst possible case, we will offer a maintenance window. Of course, our goal is to never get to a point where we need to offer a maintenance window. Our goal is for every single update, which we do multiple times a day, is to get to a point where it's just unnoticeable. And all our systems are geared and monitored in this way. How can we make sure that no impact is observed by customer, by end customers that you guys are running on, that you guys are having, your end customers, but also from our perspective, you as well, that you cannot even detect it in monitoring because the system is running so smoothly during the update. And so let's talk about 2 types of updates that Azure has. And this is kind of best of both worlds because I'm hearing our competition talking about the one on the other, but we actually implemented both. In-place migration. This is where we take the physical machine, change the components running on it, and just continue running. So for example, in order to replace a certain functionality or microcode on a CPU, we don't need to take down the machine. We can very briefly pause the VM and resume it. In most of the cases, this can happen in such a way that it's just unnoticeable by the actual code running on the customer CPU. In some cases, it might take a little bit longer and might be noticeable. But the bottom line, the multiple flavors, the bottom line, our goal is to replace it without being detected. And so here is an example. You have two nodes, two VMs on each node. After updates, both of them updated with the same VMs on the same nodes. OK, I think I have some bug in animation. Second one is, so ignore the nodes. I have some bug in animation. Oh, actually, now it works. OK, fine. So live migration. So live migration is where we are unable to update in place, and we will move you to another machine. We generally will not prefer live migration, because live migration has a period of brownout before the update, and there is an actual failover time from one machine to another. So generally, live migration does cause some deterministic behavior issues on the machines, and so we will prefer to update in place every time. But in some cases, this is the only way to go. So we will go and take VMs running on node A and node B, and in this example, move them to updated node C, in many cases, repacking the nodes. When we are performing updates, and this is, sorry, and when we are performing updates, and this is another aspect to consider, what do we care about when we are performing updates? And the reason I'm showing that once again is because you guys might care about the same things when updating your applications. So we first start in deploying in test environment. We want to make sure that our code is baking enough time in the test environment. We get the error prediction based on the test environment, what kind of error we're expected to get in production. We will go afterwards into some integration environments. Canary, by the way, is a program that we also call early update adoption program, I think. Early update adoption program. And this is where some of our customers can deploy their code in the Canary environment and get the updates before the updates hits production. It's kind of an insurance policy. I can get updates, I can try them out before they're impacting my production code. But bottom line, we are baking in Canary for some time, and then starting to go to production on larger and larger scale. And so when we say larger and larger scale, this kind of funnel is showing that as we go further, we increase the amount of VMs, increase the scope that this specific update is touching. So we are trying to go slow, and I think the key, the most important part of it is that in every specific step, we are trying to assess the customer experience after we deploy. And so this error is not just a term that we measure in production. This is something that we try to estimate in every point of time. For example, a concept of very first steps in this update, we perform something that we call saturation analysis. So we are trying to understand how extensive was the validation for that specific update versus entire environment. And so based on saturation analysis, we'll know how valid are results for the deployments until now. And so once again, it's all automated, there's no touch. Once it enters the pipeline, it goes ahead. But this is kind of a pipeline that you might want to implement for your applications as well, in order not to take your customers down with the updates. I don't think I'm putting anything new. I'm sharing anything new out. I'm sharing some of our practices. Hopefully, it's also useful for you. So I don't know, there's some guidance. You can maybe download it later, this presentation. Just basic stuff. Ensure that you have pre-validations. Make sure that you are implementing health signals as you're deploying. No manual work. I mean, no manual work. It's just running those tasks. No, it has to be no manual work. Otherwise, you'll get randomization. And of course, you need a rollback or backup plan for the risky changes. And one last thing learned from the past, every deployment, every change to the platform is an opportunity for root cause analysis. And so we are trying to do that as hard as we can, even for the successful deployments. Cool. I'd like to talk about the other concept that I think might be interesting for you and put some pointers. In Azure, when we are looking into the resiliency and downtime for the application, we are heavily using machine learning. I don't know. So I'm putting the word AI, but I don't like it. It's a marketing word. That word is machine learning. So we are doing a lot of data analysis, and we are trying to create a system that will operate itself. And from that perspective, we are talking about availability management, capacity management, customer engagement management, and things like that. We would like to get to a point where we really don't take any actions to manage the system. Why should we take any actions? It's a machine. Machines should manage machines. People should think about the new features, about new requirements. There's no value in machines, in people managing machines. And so we are actively after that. And to be super honest, we are actually trying to drive this motion across the globe. We also, with, not just with us, but also with our competitors. We are very active in the research community around AIOps area. I think Gartner calls this AIOps, and this kind of became the standard term. And it's all about creating machine learning solutions that run your production environment. And once again, the less human touch you have, the less chance for errors. 10% of every human touches eventually are done wrong. So it's better to let machines operate themselves. So we kind of define those guarding principles, like guarding principles for our AI. I'm thinking about movies. You shall not harm human, but in this case, it's somewhat simpler. We are trying to make sure that first of all, our implementations are self-aware, understand the context. We are not just doing some basic automation. We are self-operating. This means we do have objective functions which system tries to get to. So for example, based on error, we can define a set of objective functions, and system tries to do whatever it can to avoid error regression or error impact to the customers. And of course, low human intervention. This is where we allow our systems to try to repair themselves before they go and escalate to humans. And then the question is, which human should they escalate to? This is also something that we invest a lot in machine learning to reduce the cycle of escalation. And so, based on those three principles, we are performing our development. This is an area where we are heavily engaged with MSR, Microsoft Research, and if you're interested to talk about it and join some of the research forums, please come by after the talk. So, all the investments I mentioned about in the AIOps space are tightly connected to customer experience. The objective functions we define for platform improvements are tightly related to those customer experience measurements. So we define those SLIs. We are able to perform some predictions, some insights based on those SLIs. And the system tries to take actions in order to keep those SLIs as high as possible. And so we do have automated systems that their goal, their purpose is to ensure that we continuously strive to get the best possible customer experience. In many cases, by the way, it's not obvious, but it's something that machines are actually really good at, taking same actions again and again with the best possible optimization. This, by the way, changes the way we develop code, and this is interesting. This means that engineers now, instead of just defining or just shipping this piece of code, start thinking about how they integrate insights, how do they drive the behavior of their code to best serve the customer. And so I think one of the challenges we have on our side is how do we change this paradigm of development of any new code so that it continuously uses this infrastructure, this data infrastructure, to improve the customer experience. I do have an example here, and by the way, I think there's a link here to one of the papers we published around disk performance prediction. The interesting part here is that we can look into all the data around disks, and we can let the system optimize itself and decide when to live migrate customer payload out of a physical machine in case disk failure is predicted. But bottom line, this is completely automated. There are no humans, there are no thresholds here. It's all about us making an educated guess around how a certain disk will perform in production environment. So if you're interested, that's a link. Sorry, that's the name of the paper. So most of you know about tardigrade. I don't want to say it's my favorite animal, but apparently working for this team, it might become. So where we are going with Tardigrade, Mark showed demo in his session where we induce a back check and the virtual machine continues running. But we are taking it to a much deeper, much more insightful place. What we are trying to do is to change the behavior of the entire system. So in every place where we can predict that the failure might occur, we take recovery action, hopefully prior to that failure, and we minimize the blast radius. So taking the action around blast radius for your downtime is important because this means that less of your customers will be impacted. The failure might still occur, but what if only half of your customers are observing that failure? And so when you're going with this concept, this allows you to significantly improve your average customer experience despite the fact amount of failures might still not go down due to, in many cases, objective reasons. It's too hard, something we cannot do, but this is definitely a consideration to take. How do you minimize amount of customers impacted, and how do you build systems in production that can predict the failures and take actions to minimize the impact? Many of you saw Mark's demo, so I asked you in the beginning. I won't replay it. Let me just go forward. And one of the last things I want to mention for the single VMs is we do have an interface about scheduled events. If we predict that the machine is about to fail and we are going to live migrate you, your code might be sensitive, you can actually access this local IP address. I'm showing this here. And this local IP address will have an information about pending event. We generally give between 15 minutes to 7 days. It depends on the prediction. And so if you are sensitive to live migration, you could take an action. When we are performing impactful updates, or even less impactful, we are also posting events on this channel. So you can create your application to take into account. And even more, we are also posting events on this channel within the machine about customer actions. You decided to take your machine down. You can listen to this API and decide what are you doing when your machine is about to go down, what kind of configuration change you are performing. So it covers platform-initiated scenarios, in-place maintenance, user calls to restart a VM, and of course, predictable hardware failures. Let me move forward. We published some piece of example where you can create, and by the way, there was a session around it, serverless management for your infrastructure. You can actually go and create functions or logic apps to go and take care of those events. So you can create, so instead of creating a set of scripts inside your VM, inside your own environment, you can create triggers that go and react to those future events or past events. And so we have an example here that I'm referencing, but just think about the possible use cases. You can go and switch from primary to secondary VM. You can go and just log the event, all of it outside of the VM, almost at zero cost, just by using the function. So let's switch to high availability. What happens when you are able and want to run multiple instances? So let me start with, poor man's high availability scenario. This is kind of the scenario I don't want to recommend, but I do want to recognize that in many cases this could be the only option given the cost. So I do want to talk about it because it's better than running a single instance VM. Think about a case where you have two VMs, you are running them in a scale set. One of the VMs is down, you are not paying for it, it's stopped, and you will just start it when the first VM goes down. It could be a solution. Once again, don't recommend it. There's a question of how do you coordinate the updates, but at least this solution allows you to perform maintenance on your VM without taking your customers down during the maintenance. So from that perspective, it does cover you. From the perspective of having really high availability with no downtime, less. So let's talk about the real stuff. This is when we are getting to real configurations that high availability apps will run. You have multiple folders. So this one is talking about within a single DC. So one of the easiest solutions to do it is to run scale set or availability set with multiple VMs. And those VMs will, as you add them to scale set or availability set, we will distribute them across multiple fault domains. We will also make sure that your disks, either storage accounts or managed disks, are running in different fault domains as well. So from your perspective, the only thing you need to do is to give us an insight that all those 3 VMs or 5 VMs or 100 VMs are related to each other, and we will do what's needed in order to deploy them in a different set of fault domains with anti-affinity. There is a lot of configuration challenges here, and I won't go into all the parameters, but what you need to remember is that the total amount of fault domains that will enforce is limited. It's generally 3 to 5. In scale sets, it's 5. But you can still deploy 100 VMs, so it will just be spread across those 5 fault domains. And if your application is sensitive about which VMs relate to which fault domains, you might want to query that. Same interface I showed you 3 slides ago about scheduled events also has this information which fault domain you're in. So all of that can be done within the VM without accessing any management without any authentication. The interface I showed you previously is local, so when you're accessing that IP address, you don't need to authenticate. It's just a single code line to get the information about your config. One option that I'm excited to share with you is shared disks for high availability. So we are offering now virtual disk functionality. It's in preview starting H2. This means within the next months we'll get to preview. And this allows us to have 2 VMs or 3 VMs accessing the same disk. You might be familiar with that configuration from your local data centers. This is not a common configuration in the cloud. We do know that many of our customers are using that configuration in data centers. So we hope that this is useful. Guys like Windows Server failover, SQL cluster failover are using this. A lot of systems that are built in this way. And many of the Sun implementations will offer this functionality. So we recognize that. We offer this in cloud. We would like to make sure that this configuration option for high availability is useful. And so once again, the idea is you deploy your VMs in a scale set. You share the disk between them. And when a failure occurs, VM might go down, but the disk would be used by another VM, picked up by either second or third VM, and servicing customer traffic will continue. There are 2 modes that you might want to care about. There is a question of single writer or multi-writer. Is the disk appears as read-only to all the VMs but one, or whether the disk appears as read-write to all the VMs. With Ultra disks, we are offering read-write to all the VMs. With Premium disk, we are offering read-write only to one VM, where in order for another VM to write to it, there needs to be a failover event. So all in all, you should be familiar with those experiences from your local data centers. And of course, let me jump to the Holy Grail, availability zones. This indeed allows you to protect against DC level failures. Think about cooling failure scenario. Think in this cooling failure in a zone will still not take down your application. Once again, unfortunately, we did not find a way yet to deal with speed of light. It's still constant. So this means that your latency across zones will be definitely higher, and you need to make sure that your application is able to sustain that. There are a lot of applications, a lot of database implementations that are very sensitive to the latency. Eventually, when you create complex transactions, you will see customer experience degraded in the front end if you're waiting for those transactions. So it's not trivial that you always go to zones. You just need to be careful about your application design. In some cases, you might want to change the application design, not to wait on disk writes, and be better prepared for availability zones. But once again, keep in mind that this is a concern, and every time you go to availability zones, you need to keep in mind the latency. That's the most important thing. And so when we talk about zones, there are 2 types of things you need to consider. One is how do you configure your services to be zone-enabled, and what kind of platform services that support zones you use. And so those two aspects are important, and there's a major difference here. From platform perspective, you want say, services like SQL, storage, ExpressRoute to contain those primitives to support those zones. You want to make sure that when you are getting ExpressRoute, the service that platform provides is not impacted by the zone failure. So you might want to configure it correctly. From your service perspective, you also want to distribute your instances across multiple zones. And so those things together will get you to the right config. And the problem is that it's easy to miss. And this means that the only way not to miss is to perform failure drills. And I just had a presentation with Adobe on Monday. Feel free to download that presentation. I'll have a name in the last name and pointer in the last slide. And so we talked about the complex configurations they have, and they're running a pretty big shop on Azure, huge scale. And the questions they're facing with is how do they know that this whole configuration works? Given the complexities that we are seeing here, and the only answer is really get to a point where you can perform this DR drill or high availability drill, and customers won't know about it. And so if you're able to get to this maturity level where you can continuously implement those DR drills, this is when you know that your configuration is working and your customers are safe. So a couple of more announcements. Now I'm moving to the announcement section, some new cool stuff. Don't want you to get out of here without being excited about what's coming. We are adding more and more stuff to scale sets. We used to have availability sets versus scale sets, where availability sets were kind of single VMs added to the availability sets, and scale sets were more of a homogeneous VMs added to a scale set. So we are moving towards a mode where scale sets are provide Uber support for any type of VMs. We are adding more and more capabilities to scale sets. And so at this point of time, scale sets provide much larger scale support. And we are providing all the basic concepts that we have in availability sets. So my basic guidance at this point of time probably would be consider scale set first. This is where you probably get the most flexibility in configuration. Scale sets support both cross-zone and in data center deployments. We both support fault domains within data center and fault domains as each separate zone. And so from that perspective, all those in scale sets are just a configuration option. You don't need to think twice. It's more complicated with availability sets. Chances are you'll get it right on the first try. With scale sets, easier. And so my proposal, given the new support, is just try scale sets first. So we are continuing investing there. As I mentioned, we are offering much more parameters to configure around every single VM and scale set, so you can manage your VMs separately in scale set now. And we are also investing into size, automation, and deployment latency for VMs and scale sets. Proximity placement groups, that's new. So you can define, if your application is indeed sensitive, you can define a proximity placement group and add VMs to that. So proximity placement groups allows you to take your VMs and say, well, my network latency across those VMs has to be shorter than default. We will make sure that all the storage, compute resources are kind of put together. We'll still keep fault domains for you, but we'll make sure that those VMs are grouped tighter within the same part of data center, and you'll get better latency between them. Of course, one thing, just another plug-in into other presentations, you might want to consider accelerated networking if you are latency sensitive. This is, once again, when you're considering your resiliency for your app, given the conflict between latency and resiliency, you might consider what are other means, what are the other means you have in order to achieve lower latency. And definitely accelerated networking is a functionality to keep in mind when thinking about latency. Who is using placement groups? Generally very large deployments are interested in groups. Specifically, we saw a lot of SAP customers picking up on proximity groups. Our dedicated hardware instances are also using that. So if you have a SAP, very large instance of SAP with 20 terabytes, or you can make sure that it's still co-located within the rest of the compute resources by using proximity placement groups. We did see databases, generic databases, considering using placement groups to speed up the performance when latency is an issue, and so on. Another new feature is Azure Dedicated Host. It's in preview. We expect it to go to GA by end of this year, by end of calendar year 2019. You are able to ask Azure to give you a physical machine and ask to place your VMs on this machine. By the way, you don't have to specify which VMs will go where. Azure can do the placement for you and just ensure that machines are your specific machines. Why would you want that? Definitely compliance reasons, but we are also offering maintenance control in a much more granular level on those machines. This means those live migration pauses or those in-place migration pauses, you will be able to control them if you have a dedicated host. We are creating a maintenance resource provider. It's in preview as well. And maintenance resource provider allows you to bundle platform updates on this host. Given that there is no one else but your code running on that host, your code, of course, on the platform, running on that host, you can decide to slightly postpone those updates up to 30 days. So for super sensitive applications, I'm thinking gaming, this could be relevant. This could be, I'm thinking some of our gaming customers were saying that even 1 second could create a disadvantage for the player versus the other player. And so we would like to make sure that even those applications run on Azure and there are no unexpected interruptions. So summarizing what we discussed, I think the bottom line is you should go global when your data replication enables and latency allows. You should go to availability zones when your region supports zones and latency allows, and otherwise, fault domains is your solution. One last thing I wanted to mention before I finish is FastTrack for Azure. So we do have support solutions from Azure, and we do have specific direct assistance from Azure engineers to set up your environment. I would encourage you to consider this path. We are familiar with proven practices, proven tools, and we can help you architect your application to be highly resilient. We can share with you some of our practices. We will be happy to work with you together to build better and more reliable applications on Azure. And by the way, there is a booth in deployment area near, I think we're already done. Hope you joined it. If not, you can search for it in our portal, and you'll find the details around this program. Cool. Summarizing and leaving option for a couple of questions. We have 2 sessions that I would propose for you to take a look at if you found value in this session. First one is AIOps in Azure. This is happening later today, I think around noon or 12:30. And this talks more about what we are doing with AIOps on Azure. Hopefully, this could be useful for your environments. And the second one, we did it on Monday. I guess it will be available online. Adobe presented examples. Everything we discussed, Adobe presented how they're using it. So hopefully you can use those as blueprints or as references for your own application design. This is session 2266. So that's basically it. Please feel the feedback. I'll be happy to hear what you think about this session. And I'll be happy to take 1 or 2 questions. I think we have a couple of minutes, 1 minute. Any questions? Microphone.
What's the degree of this improvement being applied to another level of service like Azure App Service or Kubernetes? So how is the integration of all this stuff with this high-level platforms?
All the services you mentioned are working on the same platform. We are actually working very closely both with app services and with Kubernetes. And when you are configuring them, in many cases, they will simplify this for you, but nevertheless, those are the same concepts they're using. So everything I mentioned is valid, just slightly simpler. And they are using the same platform. Any other questions? Thank you for coming. Good luck with creating highly available and resilient applications. Thank you.